The whole point here is, with this, is that we can go from polar to rectangular and rectangular to polar. For all the points on the unit circle, did you notice that we can write a coordinate and we can write in polar because the radius on the unit circle is 1 and we just have to pick that angle. You've been going back and forth between polar information and rectangular coordinates the whole time. But now we can scale it backwards. We can scale it up and down. We can make the radius other than 1. But the problem is that we're going back and forth, and you're doing it because when you did triangles, were you doing Pythagorean theorem? And when you were doing in the angles, was that baby trig? Now we're just going to use those same formulas we've been using, and we're going to go back and forth specifically, not just on unit circle, but anything. So the whole key here is that we are going to use this equation. I don't want to use that. I want to use this. We're going to use this equation right here, where the radius is that Pythagorean theorem, and we're already aware of that. The radius of the circle is equal to the x coordinate squared plus the y coordinate squared, right? And we know that for a right triangle in the unit circle, remember that's the angle right there, that's theta. This is the x, this is the y. Hang on, I'm going to erase that. I'm going to put the theta right here. That's theta, right? So we know from that that the angle is equal to the inverse tangent of y over x, which is opposite over adjacent, right? And the inverse is only good when x is positive. And there's this whole case if it's in the fourth quadrant. But I'm not going to do that to you. We're not going to worry about this. These are the two you're going to have to use. Everybody understand that? So what did they do? They did that's the whole point is they gave us a coordinate that's polar. That means that r is equal to 3 and theta is equal to 3 pi over 4. Yeah? Yeah. That tells us that I'm going to put I have the r here, right? And I also have, there's another way there's one other part to this. Whenever we were scaling triangles, remember how way back when, if the radius was 3, the coordinates became 3 times the coordinates? Yeah. So it's the same thing. Now, the other two equations that you have to have, I'm going to give you all of this. You just have to use them, right? This is back from when we were scaling triangles. And basically, what was going on, there's colored pencils at the door. What's going on is we would say, okay, the x-coordinate is the radius times the cosine of the angle, and the y is the radius times the sine of the theta. And we did that back when we were scaling triangles, scaling circles. Remember, scaling the coordinate circle. If you can plug into that, can you plug both of those into that? That's going to give you new coordinates. Really, all you need is the radius and the angle. The easy thing is when they give you polar going to rectangular. You just plug it in to these two, and you get it. The harder thing is going from rectangular to polar. That's where we have to use the r equals square root of x squared plus y squared, and the theta equals tangent inverse of y over x. So on this one, so here, we have something in the fourth quadrant. Does everybody see that this is the fourth quadrant? Positive x, negative y. Does that mean inverse tangent's defined? Yes. Inverse tangent's defined in fourth and first. That's all I'm going to give you. I'm not going to do anything weird. I'm going to give you always first and fourth. Got it? Well, I mean, on the test. That means we're literally going to plug into this equation. Do we have x? Yep. Do we have y? Yep. Can we plug that in and get radius? Yep. Do we have y? Do we have x? Then we can plug them in and get the angle. Right? Yes, we can. We can do that. So, and I just need you to have one, this whole point about multiple angles, I just want you to get the first one. That's all I want. So you literally have to plug it in the equation. So let's try some. These are the easy ones. I'm given polar. So for this one, I am literally going to go, all right, this is polar coordinates, so that's my radius and that's my angle. So what is my x coordinate for my rectangular? Do you understand that I'm going from rectangular, which is just your regular xy coordinate, and our new polar, which is radius and angle, right? That's what we're doing from yesterday. We're converting back and forth between those types of points. Okay, x is going to be r. What's r? 20. And is x the cosine?
No, you can come in.
Oh, yes, they can come in. Let them in. Thank you. Olivia, come get the notes, and then I'll give you the rest later. All right. So, can you put that in your calculator? Yeah, you can. You should do so.
Degrees or radius?
What do you think?
Degrees.
Uh-huh.
Oh.
Uh-huh. Really? Really? Degrees. Punch it in your calculator. What do you get? Well, I can tell you. Cosine of negative 60 is a half. Because I know my unit circle. What's half of 20? So this equals 10. Look at, y'all do it in the calculator and prove it to yourselves. Y equals 20 sine of negative 60. And that's a negative square root of 3 over 2. So I know it's this from my unit circle. So it would be negative 10 square root of 3. But if you're using the calculator, give it to me the nearest tenth. What's that equal to the nearest tenth? Huh? Yes, negative 17.3. I forget. Yeah. Okay, so what does that mean? It means this coordinate right here, if I go rectangular, is going to be 10, comma, negative 17.3. If they give it exact like this on the test, can you put that in the calculator and compare it to what you got decimal-wise and make sure you got the right answer when you're doing multiple choice? Yeah. Yes, you can. Does that help? Okay, what if we're going the other way? What if we're doing something like this one? The 2, negative 2. We got to go the other way now.
Okay, I get it.
That's so great.
So it would be
So this is xy. So for this one, am I going to use the radius? So my radius is equal to the square root of what's the x squared? It's 2 squared plus the y, which is negative 2 squared. So that's 4 plus 4. Does that give me the square root of 8, which is 2 square root of 2? And can you put that in the calculator and give me a decimal? Yeah. Sure you can, but I wouldn't just yet. Don't just yet, okay? But that's my radius, right? And what's my angle? My angle is equal to tangent inverse of the negative 2 over 2. Is that a negative 1? Where is tangent negative 1 between first and fourth quadrant? Okay, we'll have one out, but is it just negative 1? Yeah, it is. And what's the angle at tangent of negative 1? It's negative pi over 4 because we're doing inverse tangent, right? So this coordinate would be 2 square root of 2 negative pi over 4. And can you give me decimal equivalents? And am I okay with that? Round to the nearest tenth. Is it that simple? Yep. Can you use those formulas? Yep, you can. So, to recap, if you're given The polar, you're using the r cosine theta and the r sine theta equations. You plug in the radius, you plug in the angle, you punch it in your calculator, you give me the decimal to 1. It's 1 decimal. Answer. If you're going from rectangular to polar, you use the r equals x squared plus y squared, take the square root. Angle equals inverse tangent of y over x. Plug them in. Give it to me to the 10th. Can y'all do that? Should you practice? All right, so we are done recording.